welcome to Ladyada.
Hey everybody, and welcome to Desk of Ladyada. Happy Sunday to you. It's me, Ladyada, here at my desk, always working on electronics of all sorts. Let's see what we've got going on. A lot of hardware going on today. So let's head over to the overhead, and I'll just kind of do every piece at a time. So the first thing is,
Focus.
yeah, hold on. We were doing a lot of overhead noodling earlier. So this is that USB host feather. I did all the testing for this and I ordered the PCBs. I don't think I showed a demo of this last time. I think we ran out of time because I have to get everything done in 30 minutes. But I just wanted to show like a quick demo of it working. So this is the Feather RP2040, and over here is a 5-volt boost converter with a nice chunky inductor. This can definitely supply the 500 milliamps, and it's using the TPS 62 something, which is a great 5-volt boost converter, so you can run off a battery. And then this green LED shows that the USB is powered. So the enable pin is on a switch, so you can depower the host. And if I go to the computer real fast, I'll show you the demo. So I've got a little mass storage demo going on here that I think it's on COM13. So I got a lot of COM ports going on here. Pardon me. It connects, it enables the power, and it connects to mass storage device, and it displays what's on that mass storage device. So let me see if this works. I plug in a USB key. Oh, and it prints out all the files. So this is a USB key with a SD card that has a Raspberry Pi file system on it. So yeah, it works. I mean, like it's VipBang PIO, and it is functional. And then just FYI, because I know we chatted last week about the examples, they're all here. TV USB. If you want, you can wire your own. You don't have to use the feather. You can just connect, positive and negative data lines to two GPIO and a RP2040 and one of our example code. So the examples are here under TDUSB/Arduino and under not mass storage, dual role. So CDC hosts bridge that connects to a CDC device, something that's a USB serial. HID, which I think we did show last time, we showed the device report. Mass storage, which is an example, I just showed the file explorer, and then device info just gives you the VID, PID. And then TAC did get the IntelliKeys. I think I showed that last week, and he's working on the IntelliKeys, and had to take a little bit of a break because we had a couple other things that became fires we had to put out. We're gonna get the IntelliKeys example. So it'll be kind of neat because I'll pull out the IntelliKeys I put on the shelf, and we'll get that working on a like a laptop or Chromebook or something. So that's one, and then the next feather. So let's go to the overhead again. The next feather is this e-ink feather Ink. So here it's running Circuit Python. It's got the e-ink circuitry on it, and you see it's connected here to just a everyday monochromatic 2.13-inch e-paper display. One of the things I wanted to verify was, so even though the RP2040 doesn't have really good low power capabilities, I did want to verify that it could do low power, like as low power as possible. And it turns out actually the Arduino core I use, the Philhauer Pico core, doesn't have low power support, but we do have low power support in Circuit Python. So if you look at this code here, which I'm running, we display that text, and then we do a pin alarm exit. It's actually not running the pin alarm code right now. Like if you're plugged into USB, Circuit Python doesn't go to a deep sleep, because if it did, it would disconnect the USB, and so it kind of pretends to go to sleep. But it does have a deep sleep pin alarm that will let me test the low power, because it'll like turn, I'll power it up, it'll display the image, and then it will turn off, and then I'll see the low power usage. So using my handy dandy PPK, I'm going to unplug USB, and then let's go to the computer because I'm going to power this. Let me disable power, turn on live view. Okay, so now what I'm going to do is I'm going to power the feather via the PPK. 1 second. And then I'm going to enable the output. So this is it. It just did it turned on and enumerated, and it's doing the into the e-ink display, and then it waits for a bit until the ink is done. And then when it's done with the ink, it goes into that deep sleep again. And then when you wait till this cycles out, you'll see the low power usage. So the low power usage, I just disabled it. That's why I dropped down to 0. Low power usage is about 1.3, 1.4 milliamps, which is, kind of what is expected. Again, the RP2040 being the first chip from Raspberry Pi is not optimized for low power. Low power is really hard to do. And most chips don't, like most companies would not optimize that on their first chip. They'd like get better and better at it. But it's still something that takes a couple of revisions to do. So assuming the Raspberry Pi Foundation makes more chips, they'll probably get better at that low power. But for now, it's not a low power chip. So if you wanted low power with the RP2040, you might want to use an external power control chip like the TPL 5111 or 5110, which you have breakouts for. Those are ultra low power timer chips that do the low power control. We also covered a couple low power timer RTC chips on INMPI, so you could check that out. So that feather, once I verified the low power, I was like, good to go. Verified it worked on battery. This is ready to rock and ready to order. So I've ordered that as well. So both those boards are good. Let me see. And then the last one I'm about to do is let's go to the overhead real fast. I'm going to finish testing the CAN bus feather. I think we showed the design, but I got the prototypes in and soldered up. Again, RP2040, stomach QT, and then this is the MCP 26525, I think is the part number. It's a MCP 5151. Sorry, MCP 2515 and MCP 2551, whatever. They're both combined together. It's the CAN controller and CAN transceiver all in one because it would fit. So far, I've tested all the GPIO. I haven't tested the CAN part yet, so I got to do that today. But that's one of the things I'm planning to do. And then finally, hold on, I had the tester and then I put it over here. So one of the things I did also this week is I'm doing more picoification of testers. So hold on, let me just move Mr. Cactus over there. This is the P3000 tester, which is the Circuit Playground Classic. I'll back up so folks can see the whole. That's my legs, and this is the tester. Hold on, more legs, more tester. Okay, great. And then I'll focus. So this tester is for the Circuit Playground Classic. So it's a Atmega 32U4. We couldn't get Atmega 32U4s for like a year. So this was, we had some stock and we ran out, and it was kind of like we tried to get chips, but honestly, most people get the Circuit Playground Express. So it wasn't the highest priority for us to get this back in stock. But we recently got a big shipment of Atmega 32U4 chips. So I'm like, yay, we can get this back in stock. And turned out that, one of the things is like, when you're like, oh, we're doing this again, you pull it out, you dust it off, and like only one out of the 3 testers worked. And so I was like, well, I could fix the testers, but the problem is the testers were using this Arduino M0 Pro, which is actually a pretty cool Arduino chip. This is one of the first 7021 boards that Arduino made. And it's actually quite nice, but it's no longer made. One of the things that made it nice was that there was the USB native and USB debug, and the USB debug went through a separate chip that was it wasn't a DAP link, it was like an Atmel ICE. So that means you could program it and do serial debugging from this port and have this for native USB, and it actually worked like kind of well. Like normally it's very hard to do native USB with these chips that have only one USB port, because that USB port is what you use to upload a program, and so then it's like when you're like plugging and unplugging constantly. But with this one, I could write the tester code and then still use the native USB to test the enumeration of the Atmega 32U4. But like I said, it's just continued. I have a couple of them, but like I was like, oh man, I don't want to have to like go back to this old code and see if it works. So I did a picoification of it. So now it uses the RP2040. You see, I can, and this was the USB host cable. I would just use a micro B to micro B cable to power it. So let me see if I just power this. I don't know if this is going to work. We'll see. And this tester, the way it works is you press the reset button to start the test. Oh, it has to be powered, which it isn't. This might be a little complicated. Hold on. has to be powered through USB. Sorry, I'm a little sniffly. I got a head cold, so that's why I'm a little more stuffy than usual. Okay, so then it programs the fuses and verifies with the flash, and then it does this little sound test, and then you have to press the button. So it tells you press the left button, press the right button to test all the neopixels, and then programs the final code. And then I think it says like look for the rainbow. So it does the Fermata demo. So this test is, about the same speed as the M0, and again, uses the RP2040 brains board, uses SPI and the AVR programming library that we wrote for Arduino. It's great because I can program the fuses and program the flash. And what's neat is the flash memory, the memory that is programmed into flash is so small, right? Because it's only 32K, that it's stored in the program memory of the RP2040 flash. There's no SD card, so it's like one UF2. You drop it in, and it's like bam. If I have to do updates to the tester and the firmware, I don't have to like juggle SD card and Pico UF2. It's just one UF2. So a nice update. We're gonna upgrade all the testers. So now I've programmed RP2040s, ESP32s, ESP32 S2s, S3s, and AVRs with the Pico brains, and all have been working perfectly. So that's what I've been up to. Okay, so next up, we're going to change directions completely.
Yeah. So
and go to the desert.
Yeah, for this, I'm going to first we're gonna break the fourth wall, whatever that is. We're gonna go to the green screen because the thing that we're gonna show is green.
It's green.
So this we picked this up for our kiddo. And these are everywhere. They're like low cost, and it's a mimic cactus.
Yeah.
So why don't you do a little demo, and then I'm gonna show some footage with our kiddo.
Hi, Cactus. Hello.
Yeah.
How are you doing?
And it plays music and all that stuff, but here's the main use of it, and I'll just show what this is what a lot of people
messing with babies.
Yeah. All right, so since we've had a kid, we're taking apart all the toys. We're also thinking of ways to make things better. We're also thinking of things like, well, ChatGPT generates tons of fictional fun stories. Great. Let's have toys plugged into that. That's kind of funny. But we thought there wasn't really any good teardowns. There was a lot of people who were just like, look, here's a chip on it. But I thought it'd be fun to have Ladyada show how this thing works. And then as part of our show if you wanted to make something like this, what you would do and where you would find the parts. So let's do, I think, the only live teardown.
Cactus Tear-Down.
Cactus Tear-Down. Well, yeah, only one cactus was harmed in this.
Yes, this cactus lives.
All right, so overhead.
Okay, so going to the overhead, we skinned the cactus.
Show the.
Okay, so this is the box. Yeah, this is the skin. So we've de-skinned the cactus, which is again green, but you can't.
We drained all the cactus.
Drained the cactus. So you took it. It's got polyfilm in it, and we pulled it out, and so it's just a fabric-y cover. And then where the stickers are, there's just like these stickers. It's where the buttons are. I'll show you that in a moment. And then we took out the one part of the plastic. There's the plastic base, which is two parts that are screwed together. And then we get to the actual electronics part. So here, okay, so we've got couple pieces here. So one is the part that rotates to dance the cactus. So it's just a piece of plastic that's bent around, and so it's like sinusoidal, and it's like this cheap tubing on it, so that when it rotates, it kind of like swirls around, looks like it's dancing. And then this is low-cost fairy lights. So we actually have these in the shop. They're kind of cool. So these are meant for like florists and stuff, but there's a really inexpensive way to add lighting. So they can be individual colors. So by the way, there's like, all the cactuses are just slightly different. They're like probably multiple factories making knockoffs of the knockoffs of the cactuses. This one uses the fairy lights. I think it's just white LEDs, and then These are enameled wires that the LEDs are bonded to, and then there's just a little dot of epoxy. These are like super, super cheap. So it's not a bad way to, and they're cool. So it's not a bad, like you could use them with the polyfill. You don't have to worry about it catching on fire. Not that I guarantee this won't catch on fire. And then underneath here is the battery pack, right? So it runs on 3 AA batteries. And then here's the electronics. There's a lot of wires. So, uh, hold on, let me de-wirify this. Okay, so this is the LEDs. So the LEDs are connected to like just a GPIO and they're turned on, they're flashed. There's the motor. The motor is a, it's a DC motor, 4.5 volt, 3-volt motor, and then it's got a belt to this gear train, and that just slows it down a lot because it's like a 3,000 RPM motor. Here's an on-off switch, which goes in here. And then we've got the speaker driver, right? Because these 2 wires are the speaker. Hold on, I feel like this kind of got a little bit twisted around. Hold on. I don't know if I can untwist this. Okay. So, these are the 2 buttons. So there's like 2 like record playback type buttons. There's a speaker. It looks like probably just like an 8 ohm quarter-watt speaker connected over here. And then here's the circuitry board. And what I like is that it's paper phenolic, single-sided, and so you get to have a really cool layout. Like it's a really beautiful layout because they have to figure out how to get, the ground all the way around. So I think like the ground plane is like the ground outer ring, basically. And then we're gonna zoom in, and then we're gonna focus in on this. Okay. So this is the circuit, and what you see is that there's not a lot going on here. For example, there's no regulator, right? So the power goes straight in from the battery, which is this black line and this red line and then this blue line. No, sorry, that's the motor. The green line here. So this green line, there's a little capacitor here. Sorry. This green line is power in. There's a little capacitor, but otherwise, it pretty much just powers all the circuitry directly. Save 10 cents. Don't need a regulator. Just need like 1 or 2 capacitors. And then this is the motor driver, I think. Blue. Yes, this is the motor driver. So the motor driver, it doesn't have a built-in motor drive. So there is a transistor here. It's a very simple MOSFET. Just a little SOT 89, I think, MOSFET to turn on the motor, turn off. You don't need an H bridge because you can spin one direction only. And then there's like 1 capacitor, 1 resistor here, just for the. Actually, this is probably a BJT, not a MOSFET, because there's a inline 100 ohm resistor. And then this is the wires to the LEDs, these enamel wires. This yellow set is the speaker. So you can see here is because they go directly into, both of them go directly in, and there's no amplifier. This is a chip that has a built-in Class AB or Class D amplifier that can drive an 8 ohm speaker. So this is a specialized audio chip. Already I'm like, okay, this is a chip that does audio specifically, because to have a built-in Class D or Class AB speaker driver for an 8 ohm quarter-watt speaker. And then also the microphone as well. So you can see here, there's a microphone. This looks like there's a capacitive bias to it, maybe. Not exactly sure. I thought it was an electret, but no, I'm not. I mean, I guess it could be an electret that maybe is surface mounted or wave soldered on. Unclear. And then the microphone also goes in directly into the chip, so that means it has a built-in microphone amplifier. There's a second chip here, and normally you would be like, oh, this chip is like a, that's the audio amplifier, right? It's actually not. This is actually the flash chip. And the reason you can tell is it's got the T25S80. 25X number is flash, right? You've got the W25 Q16s. That's what we use. 25S80 is going to be plain SPI. It doesn't have the Q, right? So it's probably just plain SPI, not quad SPI. Very, very low cost, 88 megabit probably flash. So this is probably where the memory is stored. So this chip has the program memory stored externally, probably. I don't think that this is the audio storage because it doesn't make a lot of sense to spend money on SPI flash to store the audio in, but it could be that it stores, it could be that you record it can use half of this for flash memory and half of it for the audio recording and playback. So there's this finally, it's like, okay, we looked at everything on the board. There's no LDO, there's the motor driver, there's flash memory. And if you Google this number, you'll find the data sheet for this. It's just a low cost flash memory chips. And finally, there's a mystery chip, right? It's got this cool logo, which is like a JL, but it looks like a pi symbol. And then the part number is AB22BP00 521, which and then there's some deeds here, but they're not very useful. So I was like, well, it's clearly not an American chip. It's probably a Chinese chip designed for these very low cost audio playback projects. So I thought I quickly was like, well, I might as well Google for it. So what I did is go to the computer. Thank you. I just Googled for the first. So sometimes, the secondary digits are specifications, like how much RAM they have or like the speed. So I just searched for the first couple characters. I didn't find, there's nothing with that particular part number, but, a lot of the chips look similar. And one thing that I do know is that you'll often see like rebrands, like there'll be one chip core and then they'll tweak it for a customer. So a customer's like, look, I need this audio playback chip, but I want it to have, more RAM or less RAM, or I want you to do something tweaky with the peripherals or give me a more powerful amplifier or bond in something on the chip. Who knows? So, well, I did not find that part number. I did find chips that had the same, uh, logo, which was helpful, right? Because I was like, I don't recognize this logo. And this logo is for, yeah, so I like Googled and like I found it here, and then like I was like, okay, here, and then it was like Jerry brand chip or JL Jerry. So it makes sense, right? Because it looks a little bit like a J and an L. And they make Bluetooth audio chips, and then they make also USB. This is SPI flash music player. So like very similar stuff. Um, I did find they have a GitHub, so they're called J-Lee, so Jerry, J-Lee. And they have Bluetooth SDK, so they make microcontrollers, very inexpensive microcontrollers, probably based on the 8051, maybe some RISC-V nowadays. There's some documentation for their other chips, like the AC 1082 MP3 playback chips. Looks like they're doing knockoffs of the WT 8002 series, so for those who don't know about it, WT Sound IC. They make also very similar low cost, voice recorder chips, MP3 playback, type chips for audio recording, audio playback, audio control, whatever. But this is definitely, they have an SDK. I thought it was cool. It was like, they have open source documentation. Doesn't mean it's great, but it's open source. It's a microcontroller. You can program it. So this is probably, somebody took the example of like a record and playback example, like a common thing is a record and playback greeting card, where you open it, you record a message, and then when the next person opens it, it plays back the message. But they just changed the timing, and they changed that it automatically records at all times. And then after a pause on the audio volume, it will play back the existing audio, but at double speed, right? So it's a cute, fun hack. Like it's probably using an example code that they've already got. So again, I couldn't find a data sheet. I also honestly didn't look that hard, but probably this is one of those chips that's slightly tweaked off of their existing line. AB22P. I'll tell you another thing that's quite common is, and I think it's hilarious that whenever you get these low cost toys and you open them up, or like low cost modules, the companies often sand off the part number, or they change the part number, so it's like not as easy for competitors to clone them. could be something like that as well. And then this is what it's called. It's called a mimic dancing cactus. So there's like hundreds and hundreds of sellers of these. They're all pretty much the same thing. Ironically, I bet if other people did a teardown of one of these, you're going to find a slightly different chip, because I'm sure that there's so much competition in this space to lower cost. And they could have, Jay Lee might have made a deal with one company, and then another company wants to knock them off and make their own cactus toy. They'll go to another company, and they'll use a slightly different chip and rewrite the code. But at least for now, I thought it was interesting. Audio playback chips are kind of neat. I'm going to show on the Great Search another low cost audio chip as well. But that's my teardown of the Cactus Buddy. Hello. Thank you, Cactus Buddy, for teaching us about the Jay Lee audio subsystem chip.
All right. So do you want to do the Great Search?
I do, but I want to blow my nose first.
Sure.
Give me a second.
Where in the world is that part I need? The Great Search with DigiKey.
The Great Search brought to you by DigiKey and Adafruit. Every single week, Ladyada uses her powers of engineering to help you, yes, you, find the things on digikey.com. Ladyada, what is this week's Great Search?
Okay, I'm glad you asked. So this week we did a little teardown of like a dancing cactus friend. And we found an audio playback chip inside of it that does audio recording and playback. And it reminded me that when I was in school, it was very common to make projects. If you had projects that needed voice or audio clips or props, nowadays, you can use CircuitPython, and you can maybe play audio through your Teensy board or whatever, and you can do MP3 playback in Arduino. But at the time, we didn't have chips like that. We had like 8-bit micros. And so what you did was you use an ISD audio chip. And I was like, I should see if ISD audio chips are still around. And they are. And there's quite a lot of them on DigiKey. And they do, they have more options now. They have SPI control. They used to be only push button control. I thought I would show people these ISD audio chips. They're fairly inexpensive, and they're very easy to integrate. So if you want to make a project that just has audio and you don't want to deal with microcontrollers and coding and storage and files and stuff, they work really well. And you can even program the flash directly, so that if you have existing audio clips, you program them. So let's go to the DigiKey website. Okay. So originally these were called ISD chips, but the word ISD is used for a lot of different things. So I would call them audio recording chips. And I think they were called voice record and playback. So we'll actually look at the whole category. So this category under integrated circuits interface, voice record and playback has a lot of options, but they're actually all, again, ISD chips. So, the part number starts with ISD. And I think that they were from another company originally, which I think, again, was called ISD, but they were purchased by NuvoTon. I'm actually not 100% sure about that, but I'm pretty sure. And they're called the chip quarters. And again, these have been around since I was in school. So it's been over, 20 years. But they're great. They were, again, originally designed, I think they were designed for, shoot, what's the word? It's answering machines, right? Which nobody knows about anymore. But if for those who are Zoomers and younger, people would call you on the phone, and then it would pick up the phone and it would say, "Hello, you reached Ladyada's house, leave a message, beep," and then you would be able to record the clips of the message and then play them back when you got home. Originally these used tapes, which is a whole thing where people would sell tapes with cool voice greetings, but eventually they right before they went out of business, because everyone started having voicemail, they would have digital versions of answering machines. And I think these ISD chips were commonly used because some of these have 30 seconds or 64 seconds, but some of them have 64 minutes, which is a lot. So yeah, I think that this is 64 minutes. That's there's no audio greeting card that has a 64-minute like epic poem that you have to say. I think that would be used for message storage and keeping. So that said, there's a couple different options of these. One thing that I do like is, well, let's go look at only the ones that are in stock. They're actively available and they're normally in stock, which is not a ton. There's like 500, but many of them are discontinued. So what's neat is there's a couple new things. So first off, just so you know, the sampling frequency is not that great. They tend to go up to 12 kilohertz. They're really meant for voice. They're meant for that narrow band. Voices tend to be about 2 to 8 kilohertz. So you're not going to get good musical quality. They're also compressed. And from what I recall, it's not stored as in like true RAM. I think it's stored on like floating capacitive plates. Like it's a little bit like dynamic RAM, but it like it's lossy. Anyways, just it's not the highest quality and it's compressed and everything. But they do have things like built-in speaker output, built-in microphone input. So we can look at let's look at one that has a microphone input, so you can record the microphone easily. Some of them have I2S now, which they absolutely didn't have before. So let's do that. There's one that has I2C, which I thought was neat. I'll just show that really quickly. Again, this version is new. It's a 28 dip, so it's a little pricey, but if you don't want to even make a PCB, you can wire this up on a breadboard and just connect it up. It's got speaker output, it's got line output, and it's got I2C control, microphone input. They kind of just do everything on their own. And then they have buttons that you can use to control. You can like record into each like memory slot and then have it play back. But let's not look at the interface, because I2C, although is cool, is most people I think would use the push buttons and stuff. And then we'll just sort by price and look at some of the options. You're going to pay a little bit more for the more space that they've got. I do like the SOIC versions of these. I think, yeah, so the ISD 1 series means it can play one channel, but they do have a version. They do have versions of these. They're more expensive, but they do multiple channels. So let me scroll down. So I think like the ISD 3, which maybe I'd search for separately. Oh, you know what? I should have searched from within. Yeah, so ISD 3. Or was it the ISD 2? Hold on. It could be that they were not. Oh, they don't have the microscope or the microphone input. Yeah, the ISD 2. So you have to program it with SPI. It doesn't have a built-in microphone. But these are neat because they can do multiple channels at a time. Yeah, 3-channel concurrent playback. And up to 65 watts. So you can actually have like multiple sound effects playing at the same time. So again, something that would be hard to do with a microcontroller. You can do it, but like this kind of does it all for you. So other than that, the microphone one, I would recommend if you're going to start with these, get the microphone one, because it's kind of cool. You just plug the microphone right in and you can record immediately. So microphone input. And then I liked the SOIC. Oh, there's a dip version. This is going to be a little bit more expensive because they're rarer. But you can get this dip version. I would get this, the ISD 1740py. Totally cool. Has 80 seconds of memory. And then, of course, they go up to, more 17 minutes. I don't know, like a full album, basically. But the other package I would recommend, if you don't mind doing a little soldering, it's less expensive, is get the SOIC. You can get little breakout boards, and I think the ISD 1610. That's a good option, 20 seconds, so you can do little sound effects, record and playback. Let's look at the data sheet real fast. Whoa, this is not the data sheet. This is all the different options. That's kind of cool, but that's not what I wanted. I guess this shows all the comparisons. So this is ISD AIU enabler, ISD1. Chip quarter family. Okay, so this shows you all the different options. Oh, some of them have external flash, so you put flash chip on there, much like it looks like this dancing cactus might do. This is what isn't actually the data sheet. This was the spec sheet. But let me see. Yeah, this is the audio selection guide. One moment. Let me look up. Maybe this one has a data sheet. No, it doesn't. Okay. We'll have to. Maybe this one. Okay. Yeah, this series. So you can look up the data sheet by Googling it through the NuvoTon site. But wait. There you go. Microphone input, and then buttons. So, the buttons are, playback and record, and you can, like press a button to hold, and then you press like one of the IO and you can record into that slot. So you can have like 9 different slots in each one. You can record into the slot kind of as much as you want and then play back, and it just records and plays back. And then just to be clear, when you turn off the power, the memory is still there. It's non-volatile memory. It's not SRAM. It's not quite flash, but it's not DRAM or SRAM. It's kind of like somewhere in the middle. It lasts a long time, but I think it's slightly lossy. And then looks like the whole family, each one has slightly different pinout, but SOIC is pretty easy to use. So, we use a breakout board if you want to get on a breadboard. I've made dozens and dozens of projects with these. It was my go-to because, again, at the time we had only 8-bit microcontrollers and you wanted to add audio. This was like the easiest way to do it, which is why CircuitPython playing audio was really important to me because I loved making projects that had reactive audio, especially like, capacitive touch, and then it played something and the device would speak to you. Very common interactive art. So you want to get started checking out the chip quarter series? I would get the ISD 1610. A good one to start with. And then, but check out, there's, again, dozens and dozens of them in the family, including dip ones, if you want to go straight to a breadboard.
That's a great search.
Where in the world is that part I need? The great search with DigiKey.
And that's our show this week. You need to go.
I need to have, yeah.
You need to have some tea or something.
I know. I'm sorry. I'm very stuffed up. Thank you for putting up with my
It's all good.
extra nasally nose.
It's all good. Proves that we're human beings.
I know.
This is not Midjourney or Stable Diffusion or ChatGPT 6 yet. All right. Well, we'll see everybody throughout the week. We have tons of good shows and more. Thank you so much for spending your Sunday night with us. Later, everybody.
Bye, everybody.